Welcome to Section 3, Lesson 2. In the previous lesson, we solved one-step linear equations where the variable was hidden behind a single operation. Today, we extend the workflow to two-step equations, which are the most common form of linear equation in homework, on tests, and in real-world applications across science and engineering. The variable is hidden behind two stacked operations, and the solving procedure is exactly the same balance and inverse logic from yesterday, with one critical addition: the order in which we apply the inverse operations matters. Get the order right and the procedure feels mechanical and reliable. Get it wrong and the equation becomes harder to solve at every step. Today we lock in the reverse PEMDAS rule that determines the correct order, and we walk through two clean two-step solves to make the workflow automatic. First idea on the board. A two-step linear equation has the form a times x plus b equals c, where the variable x is hidden behind both a multiplication by a and an addition of b. Two operations stack on top of the variable, and we need to undo both of them to isolate the variable. The structure is the canonical linear equation form x plus b equals c that we identified in Lesson 1, and recognizing the structure immediately tells us a two-step inverse operation procedure will solve it cleanly. Second idea. The order in which we apply the inverses is the reverse of PEMDAS. Recall that PEMDAS evaluates an expression by computing parentheses and exponents first, then multiplication and division, then addition and subtraction last. To undo the operations and isolate the variable, we apply the inverses in the reverse order: undo addition or subtraction first, then undo multiplication or division. The reverse order works because we are unwrapping layers around the variable from the outside in, and the outer layer in standard PEMDAS evaluation is the addition or subtraction layer, so it gets undone first. Third idea. The verification step at the end stays the same as in Lesson 1. Substitute the proposed solution back into the original equation and check that both sides really do equal the same number. The verification step uses the evaluation skill from Section 2 and catches almost every two-step solving error in 5 seconds. The combined workflow is therefore identify the two operations, apply the inverse of the addition or subtraction first to both sides, apply the inverse of the multiplication or division next to both sides, read off the solution, verify by substitution. Today's two examples walk this workflow end to end, and tomorrow we extend the same procedure to equations with the variable on both sides. A two-step linear equation has the form x plus b equals c, where the variable is hidden behind both a multiplication and an addition. Two operations stack on the variable, and the solving procedure unwraps both of them in the correct reverse order. Recognizing the two-step structure on any equation immediately tells you the procedure to apply. Here is the reverse PEMDAS rule that determines the order. PEMDAS evaluates an expression by computing parentheses and exponents first, then multiplication and division, then addition and subtraction last. To undo the operations and isolate the variable, we apply the inverses in the reverse order. Undo addition or subtraction first, because that was the last operation done in the forward direction. Undo multiplication or division next. Step 1 in the workflow. Identify the two operations currently applied to the variable. In the equation 2x plus 5 equals 13, x is being multiplied by 2 and then 5 is being added. Two operations, both visible from the structure of the expression. Name both operations explicitly so you know which inverses to apply and in what order. Step 2. Apply the inverse of the addition or subtraction first to both sides of the equation. To undo plus 5, subtract 5 from both sides. The left side becomes 2x plus 5 minus 5, which simplifies to 2x. The right side becomes 13 minus 5, which equals 8. The equation is now 2x equals 8, which is the one-step form from Lesson 1. Step 3. Apply the inverse of the multiplication or division next to both sides. To undo times 2, divide both sides by 2. The left side becomes 2x divided by 2, which simplifies to x. The right side becomes 8 divided by 2, which equals 4. The equation is now x equals 4, which is the goal form. Verify by substitution. 2 times 4 plus 5 equals 8 plus 5 equals 13. The original equation balances, so the solution x equals 4 is verified. Here is the first worked example. Solve the linear equation 2x plus 5 equals 13. The variable x is hidden behind both a multiplication by 2 and an addition of 5. Two operations stack on x, and the solving procedure applies the inverses in reverse PEMDAS order. Undo the addition first, then undo the multiplication. Step 1. Identify the two operations currently applied to x. The expression 2x plus 5 contains a multiplication by 2 on x and then an addition of 5 on top. The inverses are subtraction and division respectively, and the order is subtraction first because addition was the outer layer. Step 2. Subtract 5 from both sides of the equation. The left side becomes 2x plus 5 minus 5, which simplifies to 2x because plus 5 and minus 5 cancel. The right side becomes 13 minus 5, which equals 8. The equation has now been reduced to 2x equals 8, the one-step form. Step 3. Divide both sides by 2. The left side becomes 2x divided by 2, which simplifies to x because the 2 in the numerator and the 2 in the denominator cancel. The right side becomes 8 divided by 2, which equals 4. The equation is now x equals 4, the goal form, and the solution is x equals 4. Step 4. Verify by substitution. Plug x equals 4 into the original equation. 2 times 4 plus 5 equals 8 plus 5 equals 13. The original equation balances, so the solution is verified. So the solution is x equals 4. The big lesson from this example is the reverse PEMDAS order applied. Carefully subtract first because addition was the outer layer, then divide because multiplication was the inner layer. The order is non-negotiable. Applying the inverses in the wrong order forces you to handle fractions or extra arithmetic that the correct order avoids entirely. The verification step at the end uses the evaluation skill from section 2 and catches any arithmetic slips during the solving steps. Build the reverse PEMDAS habit on every two-step equation, and the workflow becomes a fast, reliable reflex within a week of practice. Here is the second worked example. Solve the linear equation x divided by 4 minus 3 equals 2. The variable x is hidden behind a division by 4 and a subtraction of 3. Two operations stack on x, and the solving procedure applies the inverses in reverse PEM order. Undo the subtraction first, then undo the division. Step 1. Identify the two operations applied to x. The expression x over 4 minus 3 contains a division of x by 4 and then a subtraction of 3 on top. The inverses are addition and multiplication respectively, with addition first because subtraction was the outer layer. Step 2. Add 3 to both sides of the equation. The left side becomes x over 4 minus 3 plus 3, which simplifies to x over 4 because minus 3 and plus 3 cancel. The right side becomes 2 plus 3, which equals 5. The equation has been reduced to x over 4 equals 5, the one-step form. Step 3. Multiply both sides by 4. The left side becomes x over 4 times 4, which simplifies to x because the 4 in the denominator cancels with the 4 we just multiplied by. The right side becomes 5 times 4, which equals 20. The equation is now x equals 20, the goal form. Step 4. Verify by substitution. Plug x equals 20 into the original equation. 20 divided by 4 minus 3 equals 5 minus 3 equals 2. The original equation balances, so the solution x equals 20 is verified. So the solution is x equals 20. The big lesson from this example is that the same reverse PEMDAS rule handles division and subtraction just as cleanly as it handled multiplication and addition in the previous example. The inverse pairs are universal. Subtraction undoes addition, addition undoes subtraction, division undoes multiplication, multiplication undoes division. The reverse PIMDES order says undo the outer additive layer first, then the inner multiplicative layer next, regardless of which specific operation appears in either layer. 2 examples and the pattern is clear. Tomorrow we extend the workflow to equations with the variable on both sides, where an extra preliminary step gathers the variable terms onto one side before the standard 2-step procedure takes over. 3 mistakes that catch every algebra student during their first weeks of 2-step equation work. Each one is fixable with a small explicit habit applied on every solve. First mistake: applying the inverses in the wrong order. A student sees 2x plus 5 equals 13 and divides both sides by 2 first, getting x plus 2.5 equals 6.5, then subtracts 2.5 to get x equals 4. The answer is correct, but the work involves fractions that the reverse PEMDAS order would have avoided entirely. On harder equations, the wrong order can introduce errors that the correct order would not. The fix is to commit to the reverse PEMDAS rule on every 2-step equation. Undo addition or subtraction first, then undo multiplication or division. Second mistake: subtracting the constant from one side only. A student sees 2x plus 5 equals 13 and writes minus 5 to the left of 2x, but forgets to write minus 5 to the right of 13, getting 2x equals 13 instead of 2x equals 8. The equation no longer balances and the solution is wrong. The fix is to write the operation explicitly below both sides of the equation with arrows or stack notation that visually commits to the both sides discipline. Third mistake: confusing the sign of the constant when applying the inverse. A student sees x over 4 minus 3 equals 2 and subtracts 3 from both sides instead of adding 3, getting x over 4 minus 6 equals minus 1. The constant in the equation was minus 3, so the inverse is plus 3, not minus 3. The fix is to read the constant in the equation including its sign, then take the opposite sign as the inverse to apply. Negative constants need a positive inverse, positive constants need a negative inverse. 2-step linear equation solving is the most common solving pattern in all of applied mathematics and engineering. Almost every formula that takes one input and produces an output has a 2-step inverse when you flip it around to solve for the input given the output. 4 broad sectors below. In physics, the kinematic equation final velocity equals initial velocity plus acceleration times time has a 2-step inverse when you want to solve for time given the other 3. Subtract initial velocity from both sides, then divide by acceleration. The 2-step pattern appears in every kinematics calculation that flips the formula around, which is most of them in real applications. In personal finance, the simple interest formula final amount equals principal times the quantity 1 plus the rate solved for the rate is a clean 2-step solve. Divide both sides by principal first, then subtract 1. Compound interest and present value formulas all reduce to similar 2-step or 3-step solves once you isolate the variable of interest. Anyone running a small investment portfolio uses this kind of solving regularly. In engineering tolerance analysis, a specification often reads as a nominal value plus or minus a tolerance, with the tolerance itself sometimes computed from a margin formula. Solving the tolerance equation for the maximum acceptable input value is a standard 2-step solve that engineers do dozens of times per design review. The skills you are building this week are the everyday currency of mechanical, electrical, and civil engineering. In software performance engineering, the total runtime of a system is often modeled as a fixed setup cost plus a per iteration cost times the iteration count. Solving for the maximum iteration count that fits within a target total runtime is a 2-step inverse. Subtract the setup cost from both sides, then divide by the per iteration cost. Every capacity planning calculation in modern computing uses this exact pattern, and the 2-step solving skill scales directly into that work without modification. 3 things to take with you from this lesson today. Two-step linear equations are by far the most common form of linear equation that appears in regular homework problems and on standardized tests, and the reverse PMDS solving procedure scales directly into multi-step and variables on both sides equations later this week. First, the two-step structure has the form a times x plus b equals c, where the variable is hidden behind both a multiplication and an addition. Recognize the structure on any equation by counting the operations applied to the variable two-operation stack means a two-step inverse procedure. The structure is the canonical linear equation form from Lesson 1 and lets you commit to the two-step workflow immediately upon recognition. Second, apply the inverses in reverse PIMD order, undo any addition or subtraction first, then undo any multiplication or division. The reverse order works because we are unwrapping the operations from the outside in, and the additive layer is on the outside of the multiplicative layer in standard expression structure. The order is non-negotiable. Getting it wrong introduces fractions and extra arithmetic that the correct order avoids cleanly. Build the reverse PMDS instinct on every two-step equation until it becomes automatic. Third, always verify your solution by substituting it back into the original equation and computing both sides explicitly. The verification uses the evaluation skill from Section 2, takes about 5 seconds, and catches almost every two-step solving error before it becomes a wrong final answer. Build verification into your standard solving rhythm as a permanent non-negotiable final step. The verification habit also has a meta benefit. It forces you to slow down and re-engage with the original problem after the mechanical solving steps, which often surfaces small misreadings of the original equation that would otherwise go undetected. Coming up next, the lesson called Variables on Both Sides, where the variable appears on both the left and the right of the equation, and a preliminary gathering step is required before the standard two-step procedure can take over. The gathering step is straightforward once today's two-step pattern is solid, and by the end of the week you will be able to solve any standard linear equation in any of the textbook forms with the same disciplined inverse operation procedure that we previewed in these two examples today. The reverse PMDS rule and the both sides discipline together form the entire mechanical core of linear equation solving across the rest of the algebra course and well into the harder solving techniques of Section 11 on quadratic equations and beyond.